All right. Sharing my screen, looks good. Okay. So I was looking at our schedule and we were supposed to start chapter 3 today, but I think it'll just be calmer if we just finish chapter 1, kind of take our time in chapter 1 today, and then we'll start chapter 3 fresh on Monday. Okay? And we're not doing chapter 2, so we don't need it, so we're not going to do it. Okay? Here's a question. I was going to say, are we all feeling sick on September 29th? But then I thought, well, that's hard to say. But the Monday, September 29th, we meet late, and it's before the holiday Tuesday. And do you want it to be just a video? I'll make a video, which means I have to make a video. So boring. No, it's not boring, but it works out nicely because it would be a kind of a way for me to introduce logic in a video, and then we can review it on the Wednesday after. And so that's kind of what I'm thinking, because I feel like a lot of people won't show up anyways. There was no question there, I guess. Do you want a video on the 29th instead of class? Obviously no class. Just getting some nods, some subtle thumbs up. You don't want to look like you're not into the course. I know, I get it. Okay. I'm ready to say yes then. Applause even. But we'll review all the topics. So I'll introduce all the topics in the video. So you have to watch the video. But then, of course, we'll do lots of examples and stuff in class on the Wednesday. Okay, nice. Hey, my smiley face didn't turn out very nice. Now it looks weird. All right. Last day, it was just on Monday, so it feels like we were just here. Okay. What did we do? We found the intersection of two lines. All right. And so we had line 1, and maybe we have a line 2. And we talked about finding the intersection of two lines where the x and the y coordinates here, right? So that x and this y is the same for both lines. And so we introduced 2 ways, but we only did 2 brief examples, so we're going to do more examples today. But we introduced 2 ways to find the intersection of 2 lines. And so we have 2 ways to find the intersection of 2 lines. The first one that I introduced was called the substitution method. And so the substitution method is my preferred method. I just feel like it makes more sense. How about I'll list the 2 and then I'll describe the 2 afterwards. And so the next one that we introduced was called the elimination method. That's the one we did an example of at the very end, but we'll talk more about it today. But just to summarize the two, let's do the substitution method. I'll make a note that I prefer this method. Well, you can say in your notes, you can say Emily prefers this method. You don't have to say I prefer it, but I prefer it. Okay? But it doesn't matter which one you use. Okay? And so the substitution method is going to go like this. Step one that we do is to, if you have the equation y equals something and y equals mx plus b and y equals mx plus b, then you can just set them equal to each other. So if the lines are, I'll say both in y equals mx plus b form, we can set them equal to each other, right? Y equals y, right? Kind of link those two up. We can set them equal to each other. And solve for x. And then use that value of x to solve for y. Then use that value of x to solve for y. The option that we didn't see for the substitution method that I guess is not part of the review, but I'm putting it into the review anyways. We'll see it in action. Is even if they're not set y equals mx plus b in that form, if they're in standard form, for example, what you can do is you can solve for one of the variables in one of the lines, right, either x or y, and then substitute that into the other line, okay? And then solve for the remaining variable. Okay? So let me write that out. And so if both lines are not in y equals mx plus b form, we can solve for one of the variables in one of the lines. Then substitute that variable into the other line. To the other line. Now it's important that it goes into the other line, otherwise you're just stuffing the line back into itself and it won't work. Then solve for the remaining variable. Page. And then, of course, use that number to solve for the second variable. Then use that number to solve for the second variable. How did I, there. The elimination method is a little bit trickier. It takes some practice, right? And so what you want to do is we use addition or subtraction of the two lines to try to eliminate one of the variables. In order to get there, we are allowed to multiply or divide the lines by any number that we want. If needed, we are allowed to multiply or divide a line by any number. Before the addition or subtraction. Before the addition or subtraction. So for the elimination method, right, you pick one of the variables that you're going to eliminate. Sometimes it's easy to spot which one is going to be easy to eliminate. Sometimes it's not, right? But you can multiply or divide any of the lines by any number that you want. Okay? And you can do both. They don't have to be the same number even. Okay? As long as you're able to eliminate one of the variables. Right? But then once you've eliminated one of the variables, then you solve for the remaining variable. Once one variable has been eliminated, solve for the remaining variable. And then, of course, use that to solve for the eliminated variable. Then use that number to solve for the eliminated variable in an original equation. You don't want to use one that you've manipulated. Ooh. Two long ways to do the same thing. Right? Let's make sure they do the same thing. How about an example? I'm going to add by the substitution and elimination method. I want to show you both. Right? But remember, you only need to be comfortable with one. Okay? On the test, right, it'll just say solve the system of equations. Okay? And it won't say by which method. Yeah? On the assignments, it'll tell you which method to use, right? But even then, if you just tell me which one you prefer and say, oh, I want to use this one instead, that's okay. I'm okay with that. It's good for practice, but you're allowed to use whichever method you want. And so here we go. What does it mean to solve the system of equations? Let's clarify that first. This is really asking you to find the intersection. Yeah? And so this says find the intersection of these two lines. X plus 2y is equal to 3, and 2x plus 3y is equal to 4. Yeah? Both of these look like they're in standard form. Okay? And they are. Yeah? And so we can still use the substitution method, but rearranging and setting them both as y equals something is going to make it pretty messy, right? If you try it, you'll see you'll end up with fractions, and ugh, you don't want to do that, right? And so which one should we start? Let's start with the substitution method so that they're in the same order that we introduce them in. To solve this by the substitution method, what's the substitution method? Let's go back. If the lines are both in y equals mx plus b, well, that's not true. So then I'm going to go to the second option because we said they were both in standard form. So if both lines are not in y equals mx plus b form, then we can solve for one of the variables in one of the lines, and then substitute that variable into the other line, and then solve for the remaining variable, then use that number to solve for the second variable. Okay. All those words make it sound harder than it is, I think. So the substitution method, first I'm going to copy down what my two lines are. Because I'm also going to describe what I'm doing, okay, I'm going to label these lines as 1 and 2. First thing you want to do is look for a variable like this one that's just on its own and easy to solve for, right? And so what I'm going to do is I'm going to solve for x in line 1. Which line 1 is x plus 2y is equal to 3. So then x must be 3 minus 2y. Nice. Now what am I going to do? Remembering that I want to take this x, so now I know x has to be 3 minus 2y. So now I can walk this into my second line, right? In fact, it's going to take the place of this x. So I'm substituting x equals 3 minus 2y into line 2. So now I'm going to write that down. Substitute x equals 3 minus 2y into line number 2. I'll start with just the original line number 2. And then I'll use I'll show that here. I'm substituting that x in for x in the other line. Because they have to be the same. At the intersection, those x's and y's of both lines have to be the same. So I get 2 times 3 minus 2y plus 3y is equal to 4. Notice how this 3 minus 2y has to be in brackets, right? Because it's one thing that I'm plugging in. Also notice that all I have left are some y's, right? And so I can expand this out, right? 2 times 3 minus 2 times 2 times y, right? Plus 3y. And so let's do that. So 2 times 3 is 6 minus 2 times 2 is 4y plus 3y is equal to 4. Now I want to solve for y. Because I only have y's left. Of course, we could have chosen to solve for y in line 1, right? And then I'd have only x's left. We could have chosen to solve for x in line 2 or y in line 2, but we picked the easiest one, right? The one with least amount of movement or math. So solving for y, I get, well, let's simplify. Let's collect these like terms first. Negative 4y plus 3y puts me at negative 1. So 6 minus y is equal to 4. Minus y is equal to 4 minus 6, which is negative 2. Multiplying or dividing both sides by negative 1, we get y must be 2. Now, we know one of the coordinates, right? Y is at 2. Now we can figure out what x must be. I recommend that you go back to one of the original equations to solve for the x, right? Just in case something happened. I'm feeling pretty good about this math that I did here, right? But you never want to rely on some math that you've done, right? And so that's why I would recommend plugging it back into one of the original equations, or if you feel confident, you can plug it into the one you solved for, right? Just because it's a little bit easier. Because here you already have x equals 3 minus 2y, and we just found that y must be 2, right? So let's see if we get the same answer. What am I doing now? Use y equals 2 to solve for x. I'll make a note of what I just said. Ideally, using one of the original equations. Using one of the original equations. Ideally. I know it's tempting. I'll use line 1. using line 1, I have x plus 2y is equal to 3. But we were also told that y is 2. So then x plus 2 times 2 is 3, which means that, oh, that doesn't look very good. X is 3 minus 4, negative 1. Before I commit to this being the intersection, right, how can you check your work? Well, we use line 1, but if x is negative 1 and y is negative 2, then the other equation, the one we didn't use, has to be true, right? So if I plug in x equals negative 1 and y equals 2, the answer must be 4 if it's true. So here, I'll just say that this is extra. We can check our answer using the other line. Line 2. Line 2 was 2x plus 3y is equal to 4. Two times negative 1 plus 3 times 2 is negative 2 plus 6, which is 4. Phew. Since our solution of x equals negative 2, negative 1, and y equals 2 is true in line 2, right, we have found the intersection. We have found the intersection. That's nice. That's a nice way to check your work. Right? A little bit extra work, but not too bad. Right? So therefore, now I'm willing to commit. Therefore, the lines intersect at negative 1, 2. Oh, I should use a different color than green for this because I was using it. Uh-oh, what color do I do? How about purple? That's weird. Whoa. Because I also said we were going to solve it with the elimination method so that you can see them and compare them. Yeah. Let's see here. So I negative 4y plus 3y. So negative 4 plus 3 is negative 1, but I dropped the 1. And that's how. Is that good? Okay. Now Okay. Gonna need a lot more room than this. And I'm curious to know which one you like better. I guess I'll find out on test one which one you choose. Choose. No, choose. Elimination method. Huh? I'll bring the question back in so that we'll have it. Copy. Paste. Mostly so that we have the lines again. Oh. So if we want to solve this, and now we are doing the elimination method, what does this look like? Remember for the elimination method, I guess I forgot to put it in the review, but you have to stack your x's and your y's and your constants, right, in standard form. Luckily, this is in standard form already. And so as long as you kind of stack them on top of each other, then you're good. And how did I? Okay. Stack the equations in standard form. So we're going to have x plus 2y is equal to 3. And we have 2x plus 3y is equal to 4. So here we have our x's. Oops. Here you want to have your y's. And here you want to have your constants. Oops, constants. Huh? Okay. We're allowed to move these lines around, right? Line 1, line 2, it's the same as line 2 and line 1. Okay. And so you're allowed to make moves like that. You are allowed to multiply, as long as you multiply the entire line by the same number, right? You're allowed to do that, or divide by the same number. You're allowed to multiply the lines by different numbers you want, right? If that helps you. Often multiplying by a negative, right? Kind of helps. Which I feel like is what I will be doing, because I don't really care to try to eliminate the y's, right? Easy to get to 1y, right, by taking line 2 minus line 1, but I want to get to 0y or 0x. Right? So I could go crazy and I could eliminate the y's if I wanted to. How? I could multiply line 1 by 3 and line 2 by 2 and then subtract them. But that's hard to see when we're starting, right? But you're welcome to try it, and that would eliminate your y's, right? So another thing we can do. What's kind of fun about the elimination method is there are usually many, many, many ways that you can do it. And so what's another way you can do it? I think maybe if I multiply line 1 by -2, that might be nice. Right, I got -2x, and then I can just add it to line 2, right? And then I get 0x. Wow, that might be nice. Yeah.
Why would you add -2?
You can do a +2, but I just find addition is a little bit easier. Right? But you can multiply by +2 and then do subtraction of the two lines, right? And it'll be the same thing. So again, I'm going to call this line 1 and line 2. And what I'm going to do, and I'll make a note here. Note, there are many options. Here is one. Oops. Combine it as one word. Here is one. Multiply line 1 by -2. So now what I have is I'm going to have -2, and then I'll put all of line 1 in brackets, just so I'm careful to multiply it in onto all three terms. X plus, oops, 2y. Careful, Emily. It's 3. And then I'm going to just copy down line 2. So again, here's line 1. Technically, it's -2 times line 1 if you wanted to do that. But because we're not doing matrices, you don't have to bother with that. And line 2. So now it gets a little bit boggy because it's proper to just keep writing out the lines like this. So now I get -2 times x, and then -2 times 2y, and -2 times 3 is my line 1. And so I have -2x plus 2y. Oh, sorry, tried. Minus 4y. What? You're a winner. It did sound like a win sound. So now, technically, we haven't changed line 2, but we did multiply line 1 by -2. And now, what I'm going to do is I'm going to add these two. Uh-oh. Add -2 times line 1 to line 2. I'll add that in there. Sorry about that. I see another reason why I wanted to do the negative here instead of subtraction, because as you saw, I usually forget to bring in the negative, especially with subtraction, so then I forget. Right? Whereas addition, I just find is a little bit easier to remember. So now let's see what we have here. -2x plus 2x is a beautiful 0x, just like we were going for. And if you wanted to not write it at all, that's fine, but I'm going to write it. -4y plus 3y puts me at -1y. Just writing out the coefficients in this line. And then don't forget the -6 plus 4.
After add the negative, why would I put negative y?
No, if you just put the -y, that's totally fine. In fact, it's usually what I would do, but because I put the 0x, I figured, what the heck. May as well put it in there. So now we have 0 minus y is equal to -2. Or we can use -y is equal to -2 to solve for y. Looks familiar, right? Because we did it already. But that's why it's nice to see the two methods. Right? Pick one you like. So y must be 2. And now use y equals 2 to solve for x. Well, in either one of the lines, let's do line 2 just to mix it up a little bit. Right. To solve for x in either of the two original lines, let's use 2. Line 2, 2x plus 3y is equal to 4. Y is equal to 2. So I get 2x plus 3 times 2 is equal to 4. So I get 2x plus 6 is 4. 2x, 4 minus 6, which is -2. So x must be -2 divided by 2. I'm just going to skip to -1. So you can do that on your calculator if you want. And again, you can check your work by plugging in that xy coordinate into the other line and making sure that it's all true. But because we already know that this is the answer, I'm just going to go for it. Therefore, the intersection is still at -1, 2. Do you mean this -2? Oh, at the start here. So it was just one of the numbers that I picked, but there are lots of other options. And it was because I picked as my goal to eliminate the x. And so for me, the easiest way to do that is to multiply by -2. But you could have, if you wanted to, you could have multiplied line 2 by -1/2, right? But then you'd have to multiply that through. And so then you get -x, which is great. But then you get -3/2, and then -4/2, which is -2. So then you'd have fractions to deal with. Right? But there are lots of options. But as long as you're able to eliminate one of the variables, that's okay. Or if you're like me and you don't like the elimination method, you don't have to use it. And I like the substitution method. Solve for one, plug it in. Yeah.
From this substitution method, when you have the x equals 3 minus 2y.
Yeah.
And you substituted the x in the other equation,
Yep.
why didn't you add a 1? Because the x has a 1 in front of it, right? Always, like it always has a 1 in front of it. So available and then y itself.
It does, but in this case, I mean, technically this is 2 times 1x if you wanted to. But really what's happening is you're taking this x and replacing this x. But what you're doing is, okay, well, this x can be replaced by 3 minus 2y. So you're just kind of walking it down. So this 3 minus 2y takes the place of x because they're
Okay.
I know that's hard to do on with my pointer on here, so that's why I had to do it on the screen, but nice. Good. Start that on a fresh page. Also, what time is it? Okay, good. Yesterday, my sense of time was so off. Usually I have a pretty good internal clock, and I could have sworn I had half an hour left, but then I was out of time. Thanks. This is what a test question will look like. Okay. It'll just say, solve the system of equations, and here are the equations. Okay. And so remembering that when it says solve the system of equations, you know that you have to find the intersection. And I'll make a little note here. This is what a test question will look like. Notice that it doesn't say by substitution or by elimination, right? It just says solve this system. And then you choose which one you want to do. Which one do you want to do? Elimination. No. It is? I think it's hard. Oh, wow. So you have elimination. Well, you get to choose which one you like. You know what we should do? If I had planned ahead, I would have said I should make teams. You guys are on team substitution, and you guys are on team elimination. And then you have a race for the solution. That's kind of fun. Maybe we should do that. Okay. Team substitution, team elimination. You're working together to solve this system of equations. You have to sit together to work together. And it's a race. Go! You guys are just racing on your own. That's all right. I tried. Have a race. How about this? You have to use the board as a group. Wow. One side each. No one wants to write on the board, including me, I know. Here's a glass. Just the solution. How about? Let's see how that. It's not easy. Now that I look at it, I guess substitution is a little bit tricky. A little bit tricky. Yes. Oh. Fine. Elimination one. In this case, I do think it might be here. Let's do them both. There. You guys didn't want to work in teams. That's okay. That's okay. It's late. All right. Let's do it by substitution, then elimination. I will say in this case, elimination will be easier. We'll do both. All right. We have 3x minus 4y is equal to 5. And we have 4x minus 5y is equal to 6. Now, the reason I say that maybe elimination will be easier in this case is because I can't see an option where I avoid fractions, right? That's okay. We can deal with fractions, but I don't see it. If I solve for x in line 1, right, then I have to divide 4 by 3 and 5 by 3. Neither of those are nice numbers. If I solve for y, I have to divide by -4. 3 divided by -4 is bad. 5 divided by -4 is bad. Oh, we're about to find out, I guess. Solving for x here, I'd have to divide everything by 4. Again, bad. Or hard, I should say, not bad. Solving for y, I'd have to divide by 5. No matter which way I do it, it's hard. Well, that's okay, we can still do it. But that's why I say in this case, because I don't see an obvious value to solve for, right, the elimination will be easier. But we can still do it. But if you don't like fractions, the elimination method will be better in this case. All right. For simplicity, I am just going to pick the first one and solve for x. Right. I'm going to solve for x in line 1. I'll clarify. I don't see any value of x or y that will be easy to solve for. So I will solve for x in line 1. I will solve for x in line 1. So I have 3x minus 4y is equal to 5, which means that solving for x, I get 5 plus 4y. And then I get x is 5 plus 4y all divided by 3. I regret the division by 3. Let me just try something. Do you see what I see? 5 divided by 3, pretty sure it's bad. Divide by 3 is always bad. It's always repeating. I say bad, I shouldn't say bad. But this simplifies to 5 over 3, which is repeating, and 4 over 3, which is also repeating, and it just makes a mess, right? Whereas if I move on, and maybe I solve for y instead in line 1, then what will I have? Just some foreshadowing. I'll have 3 divided by negative 4. You try that, 3 divided by negative 4. That's a nice number, negative 0.75. Right? What about 5 divided by negative 4? Negative 1.25. So then that might be nicer, at least. Let's do that. That will be easy to, so I will solve for y in 1. And I'll explain why. Since division by 4 will be better than 3. So here, I'll keep it there so you can try it. But I get 3x minus 4y is equal to 5. If I'm solving for y instead, then I get negative 4y is 5 minus 3x. So then y is 5 minus 3x divided by negative 4. To simplify this, right? 5 is over negative 4 and negative or minus 3x is also over negative 4. So I'm going to split that up carefully. 5 divided by negative 4 minus 3x divided by negative 4. And if you wanted to combine this minus negative into a plus, you can. But I'm going to simplify 5 over negative 4. And that was the reason I changed my plan. Because now I get a nice number, negative 1.25 minus negative 0.75 x, which is going to simplify to negative 1.25 plus 0.75 x. Harder than what we saw before. So we can still do it. Now, substitute this y. Oops. substitute y equals negative 1.25 plus 0.75x into line 2, right? The line I didn't use. Line 2 is 4x minus 5y is equal to 6. Oh, forgot if it's minus 5y. Is equal to 6. So this y, which is equal to this, is being replaced in here. So I get 4x minus 5 times negative 1.25 plus 0.75x is equal to 6. And I like to stack my equal signs. It's easier for me to do on the than on paper. Okay. We have to expand this out, but notice that I'm left with only x's. So I will be able to solve for x. So let's see here. I get 4x and minus 5 times negative 1.25 is plus 6.25. 5 times 0.75 is minus 3.75x, which is equal to 6. Collect your x terms. We have 4x minus 3.75x. And maybe I'll write it down this time. X times 4 minus 3.75 plus 6.25 is equal to 6. 4 minus 3.75. Okay. Usually I write the number. Well, it's confusing. If I pulled out a common value of x, then I put it on the left. But if I have a multiplier, which is 0.25, then I put the x on the right. I don't know why. Yeah.
Why did you write a note like that? The reason.
You can ignore it. If you're okay to jump to here.
So I was gonna do 4x minus 3.75x, which would then be.
I get 0.25, but yeah. Yeah. So if you're okay to skip from here to here, that's okay. But technically what you're doing in your head is this.
Yeah.
Right, you've kind of pulled out the x and done the math. But you're allowed to skip this line here. Okay, 6 minus 6.25. Okay. 0.25x is negative 0.25. So x must be negative 1. Got there. Okay. Now, let's use x equals negative 1 to solve for y. In which line should we use? Either one of these is fine. How about line 1? Why not? 3x minus 4y is equal to 5 in 1. 3x minus 4y is equal to 5. Forcing x to be -1 to solve for what y must be. 3 times -1 minus 4y is 5. Get -3 minus 4y is equal to 5. Oh, nice. 5 plus 3 is 8. So y must be 8 divided by -4, -2. You can check your work, confirm your answer. This is optional, but I encourage you to do it. Confirm your answer using line 2. Line 2 is 4x minus 5y is equal to 6. And to confirm, I'll put a little question mark over the equal sign, right? Because I want to plug in x equals -1 and y equals -2. And if it equals 6, then it's true. So I get 4 times -1 minus 5 times -2. Does it equal 6? And before, when I checked my work, I didn't put the question mark, but maybe that helps. -4 plus 10 is equal to 6. Phew. Therefore, the intersection is at -1, -2. I said elimination would be easier in this case. Let's try it. The elimination method. Gonna snag my lines. Okay. Again, I'm looking at this and I don't see an easy way to get rid of either an x or a y. Okay. And so, but then what we can do is we can just say, well, what if I force the coefficients of x, for example, to be the same, right? Or maybe one negative and one positive might be nice too, right? And so, with no obvious elimination, we can force the coefficients to be the same. For one of the variables. I'll do x. I tend to just pick the first one, right? If there's no obvious choice, I just go for the first one. And so to be the same for one of the variables, we will eliminate x. What's the easiest way to get the coefficients of x to be the same? We can multiply line 1 by 4 and line 2 by 3, and then they'll both be 12. So let's do that. I'll continue this sentence here. We will eliminate x by forcing both coefficients to be 12. So we have 3x minus 4y is equal to 5, and we have 4x minus 5y is equal to 6. This is line 1, and this is line 2. And like I said, I need to multiply line 1 by 4 and line 2 by 3. And then because they're both positive, I'll subtract the 2. Okay? But let's simplify this. So this 4 has to multiply into all the terms, right? And so we get 12x minus, oh, nice try, Emily. 16y is equal to 20. And then 12x minus 15y is equal to 18. And now, sorry, I'll give myself one more line. Subtract 3 times line 2 from 4 times line 1, which is wordier than just doing this. Which is really what I mean. Yeah, sorry.
I can't remember what it's called, but you just basically chose numbers and get to the other numbers. Would that be equal for x?
Yeah, so the common multiple is usually what we call it. So I like to just kind of flip-flop the coefficients, because if I just multiply them together, they will end up being the same.
Yeah.
Right, for both of them. And so, yeah, for me, I kind of grab this 3 from here and this 4 from here and force them to be 12, both of them. Yeah, you can do fancier things, but they tend to be harder. All right. Now we're dealing with the subtraction, which I personally have a hard time with, because you have to remember to bring this subtraction inside. All right. Technically just multiplying by -1. So I have 12x minus 12x, luckily is 0x, which was my goal. Now I have -16y plus 15y, which puts me at negative, I'll do 1y. And then I have 20 minus 18, which is 2. So now I can solve for y. I have -y is equal to 2. So y must be -2.
You chose to get the x to be 0.
Yeah. Yeah.
Because technically you could add, but it would make everything
Yeah. So so just remember that the overall goal is to get rid of 1, right? Because if we added, we'd end up at 24x, and then we've kind of made it bigger than smaller. So get Okay. Oh yeah, now we can use y equals -2 to solve for x. I'm gonna use, I don't know, line 1. 3x minus 4y is equal to 5. And I'm going to plug in y equals -2. So I have 3x minus 4 times -2 is 5. 3x plus 8 is equal to 5. Should it be negative? Oh yeah, all good. Phew. 5 minus 8 is negative. So x. Therefore, the intersection is at -1, -2. Good. Let me see. Okay. Good. Any questions before we move on to a new thing? Sort of new. It's all the same. Okay. So one of the most kind of common intersections that we find is in business. And it is for the equilibrium market price. So equilibrium is like this, right, where it's even. And so there's a supply curve and a demand curve. Now these are typically, they tend to be straight lines. And so in a free market economy, the supply curve for a commodity is the number of items of a product that can be made available at different prices. And so if I'm able to sell something for $10, right, that'll determine how many I'm able to make, right? If I'm able to sell it for $100 each, then I try to make a few more, right, because I can make more monies. And so the demand curve is the opposite, right? My demand for a product goes up as the price decreases, right? And so let me see. I'm going to just crop this up a little bit here. Whoops. We're not ready quite yet. Hey, come on. There. Go like this. Paste. Split them up. Okay. So usually, although in the next example, they use price as the x and the number of items as the y. But typically what we have is on the y-axis, we have the price, and on the x-axis, we have the number of items. So as the price of a product increases, so as we go up on our y-axis, okay, the demand decreases. Okay, and so what we can say is the demand, which will be like this, the demand decreases, which means people will buy fewer products. Right? So as the price increases, right, they buy very few products. And as the price decreases here, a low price, then we want to buy many items. Versus the supply curve is going to look like this. You're the supplier now, and as the price goes up, right, you want to supply more and more and more items, right? Because the price is so high and you want to make lots of money. Okay? The intersection is called the equilibrium. Okay? And so the intersection is the equilibrium. So this is where, just like we know about the intersection, where at some number of items at some price, both the supply and demand are happy, or at least stable. And so really to find the equilibrium price is usually what our goal is, right? Then we have to find the intersection of these two lines, which means we need the equations of these lines, right? But we already know how to deal with that. So the supply curve for a product is y equals 3.5x minus 14. So this is your supply. And the demand curve for the same product is y is equal to negative 2.5x plus 34. Now this is where I say it's quite unusual actually, where we're told that x is the price and y is the number of items produced. This is opposite of what is typical. But we can still work it. Okay. So just now keep track, okay? Because we were told that now x is the price and y is the number of items. That's okay. That's important to keep track of because we already have x's and y's in our equation, right? And so if we mix those up, our lines would be wonky. How many items will be supplied at a price of $10? The supply curve was y equals 3.5x minus 14. If x is the price, so here, really what this is saying is that x is 10. So y must be 3.5 times 10 minus 14. Oh boy. Oops. Which means that if the price is $10, you would supply 21 items. How about B? And I'll underline the supplied to indicate that you have to use the supply curve. And then for part B, now we want to know, well, how many items will be demanded at $10? Huh? So now we need the demand curve, which is y is negative 2.5x plus 34. If x is 10, negative 25 plus 34. That's not good. Why do I say that? I'm willing to supply 21 of these things, but people are only willing to buy 9 of them. Uh-oh. What does that mean, kind of intuitively? There is a surplus, but also the price is too high, right? We probably have to bring the price down so that the demand will go up. So, part C, well, wouldn't you know it? Determine the equilibrium price. Now we're lucky. The supply curve is given in y equals mx plus b, and the demand curve is given in y equals mx plus b. And so in this case, because we're all tired, I'm only going to use the substitution method. And in fact, I'm just going to put them equal to each other. You can use elimination if you want, but in this case, it looks messy to me. And I don't really want to do it. I'll make a note here. I will use by substitution. So I have y equals, and in fact, I'm going to write it like this. 1 on the left-hand side, 3.5x minus 14 is equal to y, which is equal to the other y, which is negative 2.5x plus 34. Because then, this kind of goes away. Right? It was just a bridge. So then I have 3.5x. I'm going to move my x's to the left-hand side, so I'm going to add 2.5x. And I have 34, move the 14 over to the right-hand side, plus 14. $3.5 plus 2.5. I'm going to go with 6x and 34 plus 14, 48. Is it 8? Yeah. So the equilibrium price, because the x is the price, is 8. Since x is the price, in this case, the equilibrium price is $8. Just as we suspected from earlier, right? I was supplying too many things, but there was only demand for a few things at $10. Well, that's because they wanted the price to be $8 to be happy. How many items will be produced at the equilibrium price? So now if we make an adjustment, and how do I? It's really asking find y at x equals 8. You can use either one of the equations. Let's use the first one because I can see it. 3.5x minus 14 is equal to y. 3.5 times 8 minus 14 is equal to y. .5 times 8. I know you guys are so fast. 28 minus 14 is 14 items. And that's where they kind of settled, right? They would supply a couple fewer because the price is lower, but there would be demand for 14. Nice. The break-even point is where the cost to produce something is the same as the revenue, right? Where you can actually start making a profit, right? Or at least a positive profit. And so in business, the profit is generated by selling products, of course. If a company sells X number of items at a price P, then the revenue, capital R is what we'll use, is the price multiplied by the number of items sold. So R is equal to P times X, where the P is the price that you're able to sell this thing at. The production costs we saw last day, right? The cost function is the sum of the variable costs and the fixed costs. And we often write them as the cost is mx plus b, right? Or fixed or variable costs plus the fixed costs, where x is the number of items manufactured. Which is why that previous example is kind of weird, because they flipped them. The slope m is called the marginal cost and represents the cost to produce one additional item or unit. The variable cost, which is m times x, depends on how much is being produced, which we talked about last day. So that's why I'm going fast. And the fixed cost, b, is the constant, and it does not change, right? And you still have to pay it no matter what, right? Profit is the revenue minus the cost. So profit is R minus C in that case. Company makes a profit if the revenue is greater than the cost, right? So if this is bigger than the cost, then you get to make a profit. There's a loss, of course, if the profit is negative. And where the revenue equals the cost is called the break-even point. And at the break-even point, the profit is 0. Now I want to grab from your formula sheet you have this. I brought this in last day, but nice to see it again. Notice the break-even point is not on your formula sheet. Is not on the formula sheet. It's a concept that you have to remember. So memorize, I guess, sort of, or just understand it. But the production cost, which is C, which is your variable cost plus your fixed cost, which you can write as mx plus b is on there. The revenue R is P times X, right? And the profit, which is R minus C, are all on there, right? So what do you need to remember? The break-even point, the profit is 0. Okay? That's what you need to remember. Because I'll ask you, find the break-even point. Like this. If the revenue function of a product is 5x and the cost function, and I'm going to replace this y with a capital C just to make it match what we were given, is 3x plus 12. Find the following. Part A. If 4 items are produced, what will the revenue be? Okay. And in these scenarios, you're allowed to assume that if you produce it, you will have also sold it, which is kind of unreasonable. But we're allowed to assume that. And so produced and sold. You don't make money until you sell it. So X is 4. And we want to find R. R is 5 times X. So R must be, oh, fine. 3 lines, yikes. 20. What's the cost of producing 4 items? The cost function is 3x plus 12. Now it's important to remember that X number of items, oops, I want yellow. X is the number of items. So now what's the cost of producing 4 items? The cost is 3 times 4 plus 12. I'm gonna just go to 24. So it cost me $24, or it could be 24,000 or whatever, but usually we keep it nice and simple. But I only made 20. Okay. Still need to sell a couple more, I think. How many more? Well, that's part C. How many items should be produced to break even? So the break even, remember, is when the profit is 0. Break even is when profit is equal to 0. We'll start there. From your formula sheet, profit is R minus C. I force the profit to be 0 because that'll be break even. R is 5x minus C, which is 3x plus 12. Being careful to toss some brackets on there because I'm subtracting. But now I can solve for x. 0 is 5x minus 3x minus 12. I can move my 12 over here, and 5 minus 3x, I get 2x. I get x must be 6 items. So you'll break even if you produce and sell 6 items. What will be the revenue and the cost at the break-even point? And so at what point do you start making money? Right? How much has it cost you? And so we want to find y. Oops. What's the revenue is 5 times x. So the revenue will be 5 times 6, which is 30. And I'll do the cost down here by the side. Cost is 3x plus 12. And the cost is 3 times 6 plus 12. Is it 3x plus 12? Oh, good. Yeah, 18 plus 12. Why? I hesitated because I thought it wasn't going to be 30, but it has to be 30 because we force them to be the same. So it'll cost you $30, but you have to make $30 and then you start making money. Nice. And I think that's it. Any questions? No. We'll start chapter 3 on Monday. Enjoy your weekend. Crazy. See you then.